everyone, and thank you for tuning in. I'm Susie Perez-Quinn, Chief of Staff at NASA. Today, we'll be discussing NASA's role in understanding climate change. I'm very much looking forward to this discussion that we're going to have today. Before we get started, I'm happy to introduce our NASA Administrator, Bill Nelson.
Thanks, Susie. Hey, everybody. Welcome to this first NASA Climate Summit. And we're coming together today during a consequential moment in the history of humanity. And it's a moment of uncertainty, a moment where finding common ground can feel increasingly impossible. And it's a moment with no shortage of great challenges that require action. Well, last month, COP27 brought leaders from around the world together in Egypt because, regardless of where we live, climate change is a grave threat to all of us. I'm very proud of NASA and the NASA delegation that attended. And they engaged leaders at COP27. And the reason for NASA's presence in Egypt last month is the same reason that we're having this summit today. Because often people don't realize that NASA is a climate agency. And of course, NASA will always extend humanity's reach out into the cosmos. Exploration is in our DNA. But NASA will also expand our commitment to the protection of the planet that is right here beneath our feet. And after all, from the satellites we launch to the instruments we develop, NASA is measuring and mitigating the impacts of climate change. What we're also doing is we're empowering people all around the globe to use our data to protect, for example, their herds from drought, their crops from extreme weather, their cities from environmental hazards. I often say that NASA is the point of the spear when it comes to climate change and earth science research. And we need to make sure that the world knows that fact. And a lot of the world does not know that. So let's think about a few of the upcoming missions and how this relates to this topic. SWAT. SWAT's getting ready to launch next week from Vandenberg. Surface Water Ocean Topography Mission. And it'll be the world's first global survey of nearly all of the water on the Earth's surface. Scientists are going to be able to use the data from this mission to better understand the global water cycle, better understand the ocean's role in how climate unfolds, a lot more. We're going to be able to determine the elevation of the oceans and the rivers, the reservoirs. Somewhere out west, one of the states has something like 300 reservoirs. It is very valuable information for them to know what the elevation of those multiple reservoirs are. And that's just one example. Now here's another mission that we have going. It's called TEMPO. It's scheduled for launch in March. Tropospheric Emissions, Monitoring of Pollution. TEMPO. And this will be the first space-based instrument to monitor major air pollutants across all of North America during every daylight hour at a very high spatial resolution. And it's going to hitch a ride on a communication satellite that's going to geosync 23,000 miles above the equator. And from that vantage point, it's going to look down at Earth. It's going to monitor the daily variations in ozone, nitrogen dioxide, and other key elements of air pollution. And why is it a game changer? Because it's going to resolve pollution levels to regions of several square miles. That's better than the existing limits of about 100 square miles. And with that new stream of data, Tempo is going to enable researchers to improve pollution emission inventories, monitor population exposure, and evaluate effective emission control strategies. Simply, NASA will help improve air quality forecasting. And then there's one of my favorites, the Earth Information Center. Every now and then I lapse into senator. Earth Information Center. That's a fancy term for, it's kind of like our climate change mission control center to monitor operations during spaceflight. So we're creating a mission control center to monitor conditions here on our home planet. And like so many of NASA's Earth science missions, this effort's going to be implemented in coordination with other agencies and partners. And the goal is simple, to make all of our data more accessible and usable for all levels of government, federal, state, local, universities, researchers, and the public, and make it available internationally also. Because it's not just going to be a physical location, it's going to be virtual. And that's especially important when you consider that 8 of the top 10 warmest years on our planet occurred within the last 10 years. It's indisputable what's happening. And it underscores the need for bold action to safeguard humanity's future. About 50 years ago, the last Apollo on the moon, 17, captured that iconic blue marble image of the Earth. And it quickly became a symbol of who we are, what we are, harmony, unity. Just in the past couple of weeks, Artemis 1, Orion, has captured close-ups of the lunar surface and taken a selfie and a similar striking view of our home planet. And protecting our planet is central to our mission at NASA. There's no doubt that addressing the climate crisis is a great challenge. So here's what we know. We better know that we're all in this together, everybody on planet Earth. And we also know that throughout our history, NASA has been a catalyst for unity. Look at the political situation. Look at the division there. We, NASA, transcend party politics. R's and D's support us alike. And we show the link between diplomacy and discovery also through international cooperation and collaboration. We bring people together because, as I often say about this incredible organization, we make the impossible possible. So let's go on exploring new cosmic shores and also protect our own home planet. Exploring and protection. Both of them must be NASA priorities in the 21st century. Thanks, guys, for letting me share this with you.
The third rock, the blue marble, Earth, home. Every person, place, or thing we know, everything we do, every memory we make, it's here on this pale blue dot. It's just one rocky planet in one solar system in one galaxy among billions. Even as we explore space, we study our home planet. We see it like no one else, an expansive ecosystem. The vegetation, the air, the water, the ice. Our data improves the way we grow food and how we manage the land we cultivate. NASA has over 20 satellites, measuring the height of oceans and inland waters, clouds and precipitation, carbon dioxide, and much more. For decades, our data has tracked how all these Earth systems interact. From above, we see the connections. Cities transition into farmlands. Tributaries flow into rivers, into the sea. Winds move clouds around the planet. Beyond these observations, NASA's ability to model and anticipate how the planet is changing helps communities around the world prepare. We see our changing planet, hurricanes, volcanoes, fires, and we see the impacts of humans, melting ice, rising temperatures. Earth's climate has changed and is still changing. Our data gives us the understanding to adapt and to protect our home planet in new ways. Our electric flight technologies will reduce fuel and save energy. We will make cleaner air travel possible. By understanding our changing world, we improve lives and safeguard our future. The future of our little rock in the universe, our Earth, our home.
That was an awesome video. Thank you. So before we get started, I want to introduce our panel really quick of folks that we're going to have a really engaging conversation about climate and NASA with. I've got Jim Reuter, who is our Associate Administrator for Space Technology. Next to him is Kate Calvin, who is our Chief Scientist and Senior Climate Advisor. And Bob Pierce, our Associate Administrator for Aeronautics Research. Joining us remotely is Karen St. Germain, the Earth Science Division Director. Hi, Karen. Hi, everyone. So let's get started. Yeah, let's start this conversation. I think let's just start with the base about climate change, Kate. What are the main causes of it, and what contributes to the changes on our planet?
So climate, if you think about it, what we have is you have incoming sunlight. Some of that is reflected back into space, and some of that is trapped as heat. So how much sunlight you have coming in depends on things like how far you are from the sun. How much is reflected back into space depends in part on the color of the Earth's surface, how much snow versus pavement. How much heat is trapped depends on how much greenhouse gases you have in the atmosphere. And what we know from observations made on and above the Earth's surface is that our planet's climate is changing. The last 8 years are the warmest since modern record keeping began. And what we know from science is that those increases in temperature that we're seeing are driven by increases in greenhouse gases from human activity. So we're trapping more heat on Earth.
Wow, that's a really good primer. And I think maybe we need to take a step back too and just also frame. I want to ask Karen St. Germain about NASA's history in understanding climate change. Have we always studied the changes on the Earth and the changes to the climate?
Yeah, it's great to be joining you all today. And yeah, NASA has been studying the Earth system since 1960 when we launched the first weather satellite, and 10 years later or so when we launched the first Landsat, and ever since. Much of what we understand about how climate is changing, the changes that Kate just described, really comes from NASA satellites. And that history of observation has allowed us to understand the processes, how the Earth works together as a system. That understanding is what allows us to model the Earth system. And when we can model the Earth system, we can begin to predict and project. And that's really how we connect NASA Earth observations to decision-making today.
Thanks, Karen. So we talked a little bit, just really quick, about climate change, and we talk about what we do to measure it at NASA and our history on it. So what are we doing about it? What investments have we made? What's our role? And I'm looking at you, Bob, because of aviation.
Yeah, thanks, Susie. So part of NASA's mission is, we call it aeronautics, right? It's the study of flight in the atmosphere and the application of technology to the aviation system. If you look at aviation, it contributes about 3.5% or so to climate change, to the greenhouse gas emissions and so forth, and that's growing over time because aviation is growing. Most of that is from the airplanes you and I fly every day, commercial aviation, the big airliners and so forth. The good news is that both, if you look historically, from the dawn of aviation to where we are today, those aircraft are 80% more fuel efficient than they were in the 1960s, right? So they burn 80% less fuel, which means they produce less carbon emissions, and that's all good. The other part of the good news is that the entire industry has adopted a goal of getting to greenhouse gas, to be climate neutral, to be net zero greenhouse gas emissions by the mid-century, by 2050. That's a really hard thing to do. There's a lot of technology that needs to be developed and adopted and so forth. But good news is, like I said, everybody, the airlines, manufacturers, the entire international aviation community has adopted that. So part of what we do here then is to develop those really challenging technologies that can significantly reduce the amount of fuel that's burned on aircraft, and to help the aviations to transition to sustainable aviation fuels that are basically biofuels, right? That the carbon in those fuels are just part of the natural climate cycle, the natural carbon cycle here on Earth. So while you burn them, they produce as much carbon. That carbon is just part of that natural cycle, and so it, on a net basis, contributes less greenhouse gas emissions.
Thanks, Bob. So when you say, you talked about sustainable aviation fuel, but is sustainable aviation a different term, or are they kind of the same thing? I hear them thrown around a lot.
Yeah, so we use sustainable aviation to mean a couple of things. One is that, in fact, it's sustainable for the environment, right? That we can continue to fly, we can continue to get the benefits of aviation, but it doesn't have the impact on the environment that it has today or it had in previous decades. The other part is that in order for it to be sustainable, it's got to be economically sustainable, right? So the bottom line is it's a commercial business, so that they're going to have to make money. So we need to do these technologies in a way that both benefit the Earth as well as make sure that people can still have access to this great resource, so tickets are reasonably priced. And that aviation is available to everybody to utilize and to get the benefits, the economic and societal and social benefits of flight.
Thanks. And Jim, because Bob said technology, I wanted to turn to you and just ask, maybe from your role with the Technology Mission Directorate, how do you engage our partners, both in the commercial, private sector side, and also maybe those internationally?
Yeah, thank you, Susie. What I'll start with is saying we in Space Tech are responsible for developing cross-cutting technologies to enable NASA's missions, as well as to help the U.S. economy. When we do that through a large number of projects and programs, and in each one of those has a different unique aspect to it. The strength of our organization is when we bring these multiple activities together, and so it's our breadth. When we look at how we can contribute to climate research, and we have four kind of categories that we're dealing with. The first category is the reduction in greenhouse gas emissions. The second category is the production of clean energy. The third category is to develop platforms and instruments to enable greater Earth observation. And the final category is data storage and mining and analysis. I'll just pick a couple of these categories and then kind of get back to your question. So for production of clean energy, the thing is, when we're another big part of our activity here and priority is our Moon to Mars campaign. And what do you need at Mars to have a sustainable presence on those planets is power. And that power also needs to be clean energy and stuff. So the activities that we're doing there directly feed and can directly support things we're doing on Earth. Like, for example, one area is a nuclear power nuclear fission power system, which would help us on the moon from the standpoint of being able to operate continuously without sunlight being present. In this case, we have strong partnerships with the Department of Energy and the Department of Defense in developing in a common approach for it. Because it may not be obvious, but right now a large part of the looking at is how do we take a nuclear reactor and stuff and put it at more of a community level. And so for the advancement in that research for the standpoint of Department of Energy is their advanced microreactors. For Department of Defense, they have the Pele project. And for us, then it's the moon. And so it's actually very related to as we go through that. Then one other example I'll pick is we had a prize and challenge activity that we selected a number of developments for autonomous sensing of technology for demonstrating that. And that's something that was a community approach. We got a lot of great ideas from that, and we're implementing some as we're going forward.
That was awesome. And I love the linkage that you made between what we're doing on Moon to Mars and here on Earth, because I think sometimes we all maybe hear a little bit of that is, well, okay, why are we doing this stuff if we're going there? And how does it benefit each other? And what's the linkage? And these tie-ins are amazing. Kate, I wanted to ask you about it because you were recently at the COP, which Bill mentioned in the opening remarks, which were the UN climate change talks in Egypt last month. How do you talk about NASA, and what do you think interests people when they learn about all of the things that we're doing from Moon to Mars to studying the Earth from above?
So I think we have, research, we have observations, we have technology, and, Jim and Bob were highlighting some of those. I think a lot of, when I talk to people in my home community, which is in climate, they often know about the Earth observations, but they don't necessarily know about the technology. And so with our Earth observations, we've been able to see the Earth, we can see what it looks like now, we can see how it's changed over time. But a lot of what we do at NASA while we're exploring and looking beyond planet Earth, we think about how that can benefit people here on Earth, just like Jim mentioned. And one of the examples I like to give is from our space operations. So on the International Space Station, we grow crops. And some of the work we've done to grow crops in space has a benefit here on Earth. So we've developed research in LED lighting that we can now use in indoor agricultural facilities on Earth. We've also done research into fertilizers that direct nutrients at plant roots at the rate they need it. So in space, that means bringing less nutrients there. On Earth, that means less nutrients going into rivers and lakes. And so we're continually thinking about, as we're exploring space and learning about other planets, what does that mean for us here on Earth?
Yeah, thank you. And I know if for those of us, there was a very small NASA delegation at the COP. If you saw Kate walking down the halls, you would have thought it was a rock star. That was the level of attention on a climate scientist. Probably just as popular as the NASA swag that we brought with us. So I want to take a turn a little bit to international. And Karen, you recently presented some of the information about our Earth science missions to the Vice President and the President of France at NASA last week. Can you share a little bit about that, and then also some about our collaboration with international partners?
Yeah, that was a real honor for us to get to talk a little bit about what we do with Vice President Harris and President Macron. Of course, we highlighted the 40 years of collaboration between the U.S., NASA, and the French space agency, CNES, in altimetry. This is the measure of sea level, sea surface height. And this is one of the fundamental observations and evidence in climate change. So we have now a 30-year continuous record in observing sea surface height, thanks to our deep and extended collaboration with France. The SWAT mission that Administrator Nelson just mentioned is also a collaboration with the French Space Agency, and that, as he said, will give us not just sea surface height, but a vivid picture of the currents and the eddies in our oceans, which which transport heat around the world and also vertically transport heat and nutrients and carbon vertically in the oceans. SWOT will also give us the levels of water in reservoirs and lakes and rivers. And also, for the first time from space, we'll be able to see depth of flooding, not just extent of flooding from space. So those are some of the near-term activities just with one partner. But Administrator Nelson also mentioned the Earth System Observatory, and that's a collection of missions that we're beginning development of now, and that will inform us for decades to come. These missions will look at the atmosphere, the land surface, the ice, and combined with our existing program of record, SWOT, and our upcoming missions, NISAR and PACE, will give us this holistic view of the Earth system at a level of detail that we've never had before. That's really going to revolutionize our understanding of how the Earth system is changing as the climate changes. But it's not just about observations. We collaborate with international partners in two other really important ways. One is extracting understanding from all those observations. Often this is captured in models. And because climate change is such an urgent challenge, we're trying to accelerate that discovery, that understanding that we get from observations through an initiative that we call Open Science. And our international partners around the world are joining us to say, hey, we need to do science out in the open, invite more people to participate so that we can discover faster. And then the third part is, once we have that improved understanding, how do we move it out into the hands of the people who need it to inform, excuse me, decisions that they're making every day? One element of that, an important element, will be the Earth Information Center, and you'll be seeing more about that very soon. But also, we have hundreds of collaborations with agencies around the world, helping them make Earth science part of their decision making. Thank you.
Yeah, thank you, Karen. Kate, also to kind of throw into this discussion, last week you testified before a Senate subcommittee about Earth observations. And I wanted to get a sense from you about the kind of questions and maybe the interests that you heard from lawmakers about NASA's work in studying the planet.
Well, I think a lot of what people notice in their own communities is that climate is changing. And so it's not just warmer temperatures globally, but we're also seeing local impacts. So more droughts, more wildfires, and impacts on agriculture. And a lot of the questions that I think people have when they think about their community is, how can I better prepare? How can I better plan? How do I understand what's happening here and use that to think about how I go into the future? And so we talked a lot about Earth observations, and one of the Landsat satellite that Karen mentioned briefly earlier, we just launched the 9th one about a year ago, and we've got 50 years of Landsat data. And that satellite gives us information about where crops are grown, about vegetation health, and it can be used for all kinds of different application areas. And so we talked a little bit about that. But a lot of challenges, it's not just what we see, it's how we get information to people. And again, coming back to what Karen said, we talked a lot about open science and accessibility and trying to make it easier to use the observations and information that we have here at NASA.
So when people ask, when they receive this information, climate information, they're starting to educate themselves about it, there's probably some questions that come to mind is, can we reverse it? Is there anything we can do to change it?
It is possible to lower warming. So if you remove more carbon dioxide from the atmosphere than you emit, then you could lower temperatures. However, it's important to note that not all impacts can be reversed. So some of the impacts that we're seeing that come with increases in temperature, like heat waves, if we lower temperatures again, we'll see less heat waves. There are other impacts that aren't reversible. Things like ice sheet melt and sea level rise are irreversible on centuries to millennia. So once you've melted that ice sheet, it takes a very, very long time to get any changes there.
Thanks, Kate. And then, Bob, it also makes me curious, sometimes there's a lot of turbulence with flights, and people have talked about changes to the climate and changes to the way people travel. I mean, extreme weather could cause a lot of disruptions. It causes disruptions now for people getting from place to place. Is there any work in your aeronautics division about the impacts of climate change to air travel?
Yeah, certainly that is an expected impact, right? The increase in turbulence in the atmosphere that will lead to turbulent conditions in flight, right? So there are things you can do to the aircraft, the operation, and so forth to reduce the impact of that turbulence without adding. The thing you don't want to do is add excessive weight to the airplane, because that just makes everything worse, right? Then you're going to burn more fuel and so forth. So there are things like active controls and so forth that might do that. There's also things we can do at the airport level to enable better decision support on how to operate those aircraft, how to move those aircraft, so we know exactly the weather conditions, sort of at a micro level, and we can do those things. But overall, I think there's two things we really are focused on. One is, in order to get to that net zero goal by mid-century, let's work the technology so that the next generation of aircraft are 25, 30% more efficient than they are today, which is if you know how much technology on those airplanes today, that's a really challenging thing to do. So we're going to look at airplanes that look different. We're going to make hybrid electric airplanes, right? So big airplanes that'll operate like Priuses, those kinds of things. We're going to help with things like sustainable aviation fuels as a big national goal to get to essentially have enough sustainable aviation fuels to operate the entire fleet by the mid-century. So that's like 35 billion gallons a year of sustainable aviation. That's huge. We don't have a direct role, but we characterize those fuels. We look at how they either contribute or not to things like contrails. So if you see how contrails form, and those are that layer of cloudiness that comes out behind an airplane, it's just water vapor, right? But it turns out one of the greenhouse gas emissions, in fact, is it's called aviation-induced cloudiness. If you sit out in the evening sometime when the conditions are right and you see airplanes fly over, you can see those contrails spread out into a layer of cirrus cloud layer, and that actually can further reduce the amount of heat that leaves the atmosphere and contribute to warming. So the things we can do to characterize sustainable aviation fuels for their ability to either produce more or produce less contrails, and try to do things that'll produce less contrails. So we're doing things like that. The other thing I wanted to raise as well, and that it gets to sort of the mitigation of climate impacts. So wildfires is a big issue. And today, aviation plays an important role in fighting wildfires. But if you understand how it works, they only operate those aircraft during daylight hours. They don't have a lot of aircraft in the area because there's not automated control of those aircraft. And so you can only fly so many of them. And they do important things like drop water on fire, they surveil the area, they provide some communications, other things. We think we can solve a lot of those issues to make aviation much more impactful in the fighting of wildfires. And so that's another thing we can do through the aviation arena to do more to help mitigate some of these long-term impacts.
So you were getting right into kind of the closing question. Since we framed the problem, we framed what we know about it and what we're doing and what people think about NASA by the questions that we get and the research products that we put out. What can people do, like at an individual level, or what do you want them to know about what NASA's doing on the climate change front? So we can kind of end this on a positive note, because it is a really big challenge, and we're also really equipped to do some things about it. So Jim?
Yeah, we do a lot of prize challenge and competitions that are open call, both internal to NASA and to the community at large. Crowdsourcing is an enormous tool that we use on almost every project that we bring forward now, because you can get such a broad range of activities and ideas from the entire community that you don't usually reach normally. And so that kind of activity we have planned as part of our contribution as we're going forward. It's a place where we directly engage with people all over across the U.S.
Just to add to that, we also in the Science Mission Directorate have a lot of citizen science projects that are related to climate. So people can help us do science and help us understand Earth and how it's changed. So we have everything from, an app on your phone where you can help us understand coral reefs and categorize them, to taking pictures of clouds, and you can contribute to NASA science that way.
One of the things we've done is increase our engagement with the nation's universities. The next generation of scientists and engineers, we want them to be ready to tackle these issues, right? So we've put out, through our University Leadership Initiative, we've put out solicitations to come up with the best ideas you have to improve aviation, and then we'll give you a set of resources and go after it and do it. And it's really, we get hundreds of responses to that every year, and we select the best ones, and we're educating hundreds of students that are going to be that next generation of leaders, and that's going to make sure that we get to where we need to go.
Thank you. We're coming up on time, even though I could sit here all day with these three amazing people and you, Karen, on the screen in California. Thanks for joining us. Just wanted to close up how we ended on this note, that from up above, from decades of observations about the planet, about our planet, the best planet maybe, to prizes and engagement and the scientists of tomorrow. So thank you all, and we look forward to continued conversations.
For more than 50 years, NASA has been collecting and providing data on Earth's land, water, ice, and atmosphere. Now, a new era of Earth science has begun. Together with international partners, NASA will launch the SWAT mission to provide the first ever global survey of Earth's surface water, the oceans, lakes, and rivers that affect all of us. But we also need to understand our planet as a complex whole. That's why NASA will launch a fleet of state-of-the-art satellites forming the Earth System Observatory, which will create a comprehensive 4D view of Earth, from bedrock to atmosphere like never before. The Earth System Observatory will arm us with crucial data to help us address climate change and protect our communities. But how do we get this critical information to the people who need it? Introducing the Earth Information Center. NASA, working with our federal partners, will equip decision makers with the information they need to mitigate, adapt, and respond to climate change. We will create a greenhouse gas monitoring system and make data about our changing planet accessible to those who need it most. New satellites observing in the sky, and an information center here on Earth, protecting our planet for the next generation.